Today we will discuss about low pass RC circuit as integrator. Low pass RC circuit is a simple RC circuit which consisting of only two elements R and C. Okay, but the output is taken across capacitor. And remember that both the elements are in series. So same current flows through both elements. Now we will see how it is acting as integrator. The meaning of integrator means output must be integrated version of input. Response of low pass RC circuit must be equal to integral version of input signal that you must get. That means we are going to prove V0 of t is proportional to integral of V input of t. Are you going to get this one or not? That we are going to check. So we know that V0 of t. V0 of t means voltage across capacitor. That can be written as 1 by C integral I of t dt, where I of t is the current flowing through the capacitor. Okay, where I of t can be written as I of t is the current flowing through capacitor, which is the same current flowing through resistor. If you assume voltage across resistor as VR of t, then current flowing through resistor can be calculated as VR of t by R. VR of t by R. Okay. Next, assume that if RC is very large compared to t. RC means circuit time constant. That is this RC circuit which has time constant as tau. Tau is equal to product of R into C. And capital T means the time duration where the input signal is present. That means how much time you are applying input signal for the circuit. That duration is indicated with capital T. Okay. So if RC is very large compared to T, okay, then capacitor rises slowly towards the input voltage and it cannot reach final value, because you are going with only very small time the input voltage is applied. We know for a capacitor to charge towards final value, it requires 5 time constants of time. That is 5 tau amount of time it requires for a capacitor to reach the final value. But how much time you are applying is only for the small duration, which is very small compared to RC. That means it is very small compared to 5 times of RC. So capacitor cannot reach the final value. It even not able to reach a significant amount. So VC of t, voltage across capacitor, is very small in this case, because capacitor cannot able to charge. It requires minimum 5 time constants of time, but you are applying the input signal for a very short duration. Then where the input signal should appear, then the remaining voltage should appear across resistor. For example, if you are applying 10 volts and it has taken only 0.1 volts, since you are applying it for a small duration, then where 9.1 volts should reach, 9.9 volts should reach across resistor. According to KVL, the total input voltage should drop across the elements in the loop. So from this we can say the entire voltage VR of t is approximately equal to V in of t. If RC is very large, entire input is dropping across resistor. This is important. Now I of t for this case can be written as, instead of VR of t, I am writing it as V in of t by R. So substitute this I of t in V0 of t for this condition. So for RC far greater than t, V0 of t can be written as 1 by C integral I of t is replacing with V in of t by RC into dt. So R can be taken outside. V0 of t is equal to 1 by RC times of 0 to t V in of t dt. That means output is integral version of input signal. So we have proved this one. V0 of t is proportional to integral of V input of t. So low pass RC circuit can act as integrator only for the condition as RC should be very large compared to T. Remember this one. Okay. Now we will see what happens when different types of inputs are applied to low pass RC circuits. So now low pass RC circuit acts as integrator. If you apply a impulse signal, so here input we are applying and the output is integral version of input. So for example, if you apply an impulse signal, okay, this is defined as delta of t. So what will be the output if you apply impulse input? Impulse input if you apply, what you are going to get is you are going to get a step signal as output, and the magnitude of this one is 1. If you apply delta of t, the magnitude is 1. If you apply 5 delta of t, the magnitude is 5. If you apply some 100 delta of t, magnitude is 100. If you apply minus 5 delta t, the magnitude is minus 5. You will get a negative step. Okay. How you are going to get it? V0 of t can be written as 1 by RC multiplied by, okay, it is approximately, okay, so we'll write like this. V0 of t is proportional to 0 to infinity Vi of t. Vi of t means, here we are writing it as V0 of t is proportional to 0 to infinity and delta of t into dt. We know that delta of t, integral of delta of t, this is equal to area under delta of t. Always area under delta of t is 1. So directly V0 of t is proportional to a constant. That constant is nothing but magnitude of delta of t, area under this. So you are going to get a step signal constant for entire time duration. Next, okay, if you apply step signal, then you are going to get a ramp signal, because constant voltage, when a constant voltage is applied, constant integration is time dependent. So you will get like this. If it is something as V volts you applied, so the duration is V into t. Magnitude of step signal will be equal to slope of the ramp output. Okay. So if you apply impulse input, you will get step output. Otherwise, if you apply step input, you will get ramp output. Okay. And if you apply square wave input, then the output is triangular. Okay, the output is triangular. Outputs. If you apply, okay, parabolic input, ramp, if you apply ramp input, you will get parabolic output. Okay, so these are the different input signals you can apply. For that one, what will be the response of low pass RC circuit? Ramp input means t integration is t square. T square is nothing but parabola. So ramp input will give the parabolic output waveform, square wave input will give triangular output waveform, step input will give ramp output waveform, impulse input will give step output waveform. Condition for perfect integrator. We know that one LPRC circuit can act as integrator if RC is very large compared to T. And if you apply sinusoidal inputs, the output is also of sinusoidal, because low pass RC circuit is a linear circuit. We know for a linear circuit, if you apply sinusoidal input, output is also of sinusoidal in nature, but there may be a change in the magnitude as well as there may be a phase shift introduces between output and inputs. Okay. So for example, if you apply it as this is sin theta you applied, the output of integrator is minus cos theta. Same minus cos theta can be written as sin of 90 minus theta. Sin of 90 minus theta. So you can write it as sin theta minus 90 minus of the phase shift introduced is 90 degrees. Okay. So when a sinusoidal input is applied, there may be a phase shift of at most 90 degrees for a perfect integrator. Perfect integrator should give 90 degrees phase shift. Okay. And already we have defined the phase for a low pass RC circuit when we are discussing about response of low pass RC circuit for a sinusoidal input, where we have seen the magnitude relation as well as phase relation. Now I am indicating only phase relation from that one. Pi can be written as minus tan inverse FH by F by FH. F by FH, where minus tan inverse F divided by FH means 2 pi RC, 1 by 2 pi RC. So that can be finally you can write it as that 1 by 2 pi RC, if it is coming into numerator it will become 2 pi f RC. So pi is equal to tan inverse minus tan inverse omega RC. This must be equal to minus 90 degrees. And minus minus if you get cancels, so the maximum phase, okay, should be equal to 90 degrees and the value is tan inverse omega RC should be 90 degrees. So if omega RC is equal to 14, then pi is equal to tan inverse of 14, which is around 87 degrees. Okay. 84 degrees. It is around 84 to 85 in between. And if omega RC is 20, then approximately it is 87 degrees. So if you take omega RC is greater than or equal to 14 or 15, then the phase angle is greater than 85 degrees. Greater than or equal to 85 degrees. So we can make the condition for perfect integration as omega RC is equal to 15. That means 2 pi f RC is equal to 15. From this one, RC can be written as 15t divided by 2 pi. If this condition satisfies, okay, if this condition satisfies, then we can say a low pass RC circuit can perfectly act as integrator. This is condition for low pass RC circuit to act as perfect integrator. Thank you.